Namaste everyone, and here is a problem. A layer of ice 0.15 meter thickness has formed on the surface of a deep pond. Over the pond, we have a ice layer of thickness 0.15 meter already existing. If the temperature of the upper surface of the ice is a constant and is equal to that of air, which is minus 12 degrees Celsius, that means the outside surface of the ice is at minus 12 degrees Celsius. That is the temperature of the atmosphere. Then what is the time taken to increase the thickness by 0.2 millimeters? So the thickness of the ice layer will be increasing, and how much time will be taken to increase the layer to increase its thickness by 0.2 millimeters? Extra 0.2 millimeter thickness ice has to be formed, and all the data you have, everything given. Now the problem should be understood properly. Imagine that where the layer of ice is formed all over the lake and or pond, it is not formed at one corner of the pond because temperature of the atmosphere will be falling equally throughout in a region where the pond is existing. So if I take the surface of the pond like this, then if A is the area of the pond, and already there is a pond and it is having an ice over the full area covered, and it is having a thickness of so like this. I have to cut this now. Let's join it here. Yes. Like this. Yes. This is the area, and area below is also same here, area of the ice. And this is already having a thickness of 0.15 meters. And remember, here is water, which is ready to convert into ice. So here is water, and that is at 0 degrees Celsius. Because very next layer of ice, if it is formed, then it is this water which is converted into ice. The very next layer of water which is in contact with the ice will be formed into a new layer. So we want that extra layer has to be formed here below, and its area is also same. So this is the extra layer of the ice formed. And if this extra layer of ice has to be formed, heat from this 0 degrees Celsius should flow to minus 12 degrees Celsius, because we know always heat flows from higher temperature to lower temperature. 0 is higher temperature and minus 2 degrees Celsius is lower temperature. So 0 degrees Celsius water loses heat energy in this direction. I'll change the color to indicate it. 0 degrees Celsius water loses heat energy in this direction and gives the heat energy to minus 12 degrees Celsius atmosphere. Thereby losing the heat energy, this gets converted into ice. So they are asking now, how much time is required to form 0.2 millimeter thickness of ice extra? This extra ice has to be formed. And if this extra ice has to be formed, what is the heat energy to be removed from this amount of water, and how much heat energy must flow from this amount of water to outside so that this gets converted into ice? And you know the formula for the flow of heat energy through a conductor, a heat conductor, is Q is equal to K, area of that cross-sectional surface, and delta theta, temperature difference, time for which the heat flows, into the distance between the faces. You can write it as L or something else. Okay. Now, if this much extra layer of ice has to be formed, then how much heat energy has to be removed from that amount of water so that it gets converted into ice? You know that L is the latent heat of ice. That means L is the amount of heat required to convert m kgs of water into ice. And if you want to convert, L is the amount of heat required to convert 1 kg of water into ice. Latent heat of ice is the amount of heat required to convert 1 kg, I am talking about SI system, 1 kg of water into ice. 1 kg water into ice. Now, to convert m kgs of water into ice, say this extra layer makes m kg. Let us assume that extra layer makes m kg. M kg of ice or m kg of water. To form that extra m kgs of ice, How much heat energy has to be absorbed from this water? ml, because you know the cross multiplication. 1 kg requires L amount of heat. M kg requires how much amount of heat? ml. ml is equal to Ka delta theta into T by D. Now, again, this m kg of ice is formed by this much of thickness. That is what they say, 0.2 millimeter thickness of ice. Now, how much it weighs? What is that mass of this extra ice thickness formed? You know that that extra ice formed should have a thickness of 0.2 millimeter and it should have an area A. So can I convert this mass as density into volume? Density into volume into the latent heat, because ml is equal to Ka delta theta into T by the distance between the faces. Now, volume can be written as, so when you have that extra ice like this formed, its volume can be written as area into thickness. This area into this thickness, that is 0.2 millimeter. Area into this thickness. So if I can form, or I'll write this as X, extra thickness as X. That's what I have to, okay, I have to find out the time. This extra thickness is 0.2 millimeter. So I can write this as rho density, volume, area into thickness, because volume of this extra is formed is area into thickness, latent heat, K A delta theta into T by the distance between the two faces. Now area gets cancelled. So however large the pond is, we are not bothered here, because atmosphere will be covering the pond throughout. So no problem. So what is this T? That's what you have to find out. So I can convert this formula to T, time required, rho x L D. This distance between the already existing ice, that is 0.15, because heat has to flow through this 0.15 thickness of ice. Rho xl d divided by K delta theta into time. Hope you are following. Heat has to flow from this phase to from this phase to this phase through a distance of 0.15 meter. One thing, and that makes the loss of heat for this much of water, and a new ice layer will be formed here. Okay, so because while substituting the values, you should be careful. Now T is equal to rho, density of water. It is given density of water. Density of ice is 910, because thickness, that extra ice mass we are writing now here, 910. The thickness of extra ice has to be 0.2 millimeters, 10 to the power minus 3. And the latent heat of ice is given. Latent heat of ice is 334 into 10 to the power 3. 334 into 10 to the power 3, yes. 334 into 10 to the power 3. And D, the distance between the two faces through which the heat energy has to flow, that is this 0.15 meters, 0.15 divided by K, thermal conductivity of ice, already formed ice, 2.22 watt per meter per Kelvin. So 2.22. And temperature difference is higher minus lower. Higher minus lower is, that is 0 higher, lower is minus 12, 0 minus of minus 12. 0 minus of minus 12 into time here. Oh, how did we get 2 times here? No time here. This time is not existing here. This time is equal to rho xl d divided by K delta theta. Yes. So this is what you have to solve. T is equal to this and this will get cancelled. 10 to the power 3 and 10 to the power minus 3. Rest of the things are only the numbers, and this is plus 12. So you can directly calculate it. 910 into 0.2 into 334 into 0.15 equal to divided by 2.22 equal to divided by this 0 minus of minus 12 is plus 12. that comes to 342.27 seconds, or 342.3 I can write. 342.3 seconds. Of course, you can keep it as it is, need not convert it into hours or minutes. 342.3 seconds. That is the answer. So only the things needed here are how this whole situation is happening. One thing is heat energy from 0 degrees Celsius water will be flowing outside, which is at lower temperature surrounding atmosphere, through the ice, and then the extra layer of ice will be formed. As this 0 degrees Celsius water loses heat energy to outside atmosphere, extra layer thickness ice will be formed. So all the terms has to be substituted properly because there are so many distances, so many areas and everything. Thank you. This is the answer finally.